Hello students, welcome to this lecture on polynomials. So now we'll discuss exercise 2.1. So in first question here we have which of the following expressions are polynomial in one variable and which are not. Okay, and state reasons for your answer. So let us see first one. So in first one here we have 4x square minus 3x plus 7. Okay, so let us check whether this expression is polynomial in one variable and one not. Okay, so let us see the answer. So here we have 4x square minus 3x plus 7. So here the power of x are actually 2 and 1 here and 0. Okay, so here the power of x are actually whole number. So yes, this expression 4x square minus 3x plus 7 is a polynomial in one variable x. Okay, so now let us check second one. So in second one here we have y square plus root 2. Okay, so is this expression a polynomial? So let us see. Here basically this expression y square plus root 2 is a polynomial since here the variable y has power whole number, that is here 2. Okay, so yes, this expression y square plus root 2 is a polynomial in one variable y. Now let us see third one. So in third one here we have 3 times root t plus t times root 2. Okay, so is this expression a polynomial? So here you can see here this expression actually not a polynomial. This is not a polynomial because it can be observed that the exponent of variable t in term 3 times root t is 1 by 2, which is not a whole number. Okay, so therefore this expression 3 times root 2 plus t times root 2 is not a polynomial. Okay, so now let us see the fourth one. So in fourth one here we have y plus 2y. Okay, so here this expression y plus 2y is not also a polynomial since here you can write y plus 2 by y as y square plus 2 by y. Okay, or you can write y plus 2 times y to the power minus 1, and here the exponent of variable y is minus 1, which is not a whole number. Therefore y plus 2 by y, this is not a polynomial. So now let us check this one. So here this expression x to the power 10 plus y to the power 3 plus t to the power 50, this expression actually here we have three variables x, y and t. So this is not a polynomial in one variable. This is actually polynomial in three variables. Okay, so therefore this expression is not a polynomial in one variable. So now let us move to the next problem. So in next problem here we have to write the coefficients of x square in each of the following. Okay, so we know if we have a polynomial, like suppose a naught plus a1 x plus a2 x square plus dot 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 plus an x to the power n, then here a naught is the coefficient of x naught, x to the power 0. Okay, and a1 is coefficient of x, a2 is coefficient of x square and so on, and n is coefficient of x to the power n. Okay, so here we need to find the coefficient of x square. So in first one here we have 2 plus x square plus x. So here the coefficient of x square is basically 1. Okay, so here 2 plus x square plus x, in the above expression the coefficient of x square is 1. And let us see second one. So in second one here we have 2 minus x square plus x cube. Okay, and here the coefficient of x square is basically minus 1. Okay, and third one we have pi by 2 x square plus x. So here the coefficient of x square is basically this is pi by 2. Okay, so the coefficient of x square in this expression pi by 2 x square plus x is basically pi by 2. Okay, and now let us see this expression. So here in this expression root 2 x minus 1, here the coefficient of x square is actually here 0, since here the term with x square is not involved in this expression. Okay, so here the coefficient of x square is basically 0. And now let us move to the next problem. So in next problem, here we have to give an example each of a binomial of degree 35 and a monomial of degree 100. Okay, so let us give the example. So here degree of the polynomial is basically the highest power of the variable in the polynomial. Okay, so binomial, that means two terms present in polynomial. Okay, that case we said that polynomial is binomial. So binomial has two terms in it. So therefore binomial of degree 35 can be written as x to the power 35 plus x to the power 34. Okay, so the binomial of degree 35 can be written as x to the power 35 plus x to the power 34. And now monomial, that means one term present in polynomial. So monomial has only one term in it. So therefore the monomial of degree 100 can be written as x to the power 100. So here we give example of our binomial of degree 35. That is actually here we give x to the power 35 plus x to the power 34, and a monomial of degree 100 is basically x to the power 100. So now let us move to the next problem. So in next problem, here we have to write the degree of the following polynomials. Okay, so in first polynomial, here we have the expression 5x cubed plus 4x squared plus 7x. Okay, so we know the degree of the polynomial is basically highest power of the expression, okay, of the polynomial. So here the highest power of this expression is basically 3. So here degree of the polynomial is the highest power of the variable in the polynomial. Okay, so here in this expression 5x to the power 3 plus 4x squared plus 7x. Here this is a polynomial in variable x. Okay, and the highest power of the variable is basically highest power of the variable x is basically here 3. Okay, so therefore the degree of the polynomial is 3. And now let us see second one. So in second one, here we have 4 minus y square. So here the highest power is basically y. Highest power of the variable y is 2. So this is a polynomial in one variable y, and the highest power of the variable y is 2. Therefore the degree of the polynomial is 2. And now let us see third one. So in third one, here we have 5t minus root 7. Okay, so in this expression here, this is a polynomial in variable t, and the highest power of the variable t is 1. Okay, therefore the degree of this polynomial is 1. And now let us see fourth one. So in fourth one, here we have this, actually we have constant, and we know for a constant polynomial degree is always 0. Okay, so 3 can be written as 3 times x to the power 0. So here the highest power of the variable x is 0. Therefore the degree of the constant polynomial 3 is 0. And now let us move to next problem. So in next problem, here we have to classify the following as linear, quadratic and cubic polynomials. Okay, so in our previous lecture, there we have studied about linear, quadratic and cubic polynomials. So let us see first one. So in first one, here we have x squared plus x. So we know this concept. Linear polynomial has its degree as 1. Okay, and quadratic polynomial has its degree as 2, and cubic polynomial has its degree as 3. Okay, so linear polynomial, quadratic polynomial and cubic polynomial has its degree as 1, 2 and 3 respectively. So here first one, here we have x squared plus x. So here the degree of this expression, degree of the polynomial is 2. So this is actually a quadratic polynomial. And second one, we have x minus x cube. So here the degree of this polynomial is 3. Okay, so here the highest power of the variable x is 3. So degree of x minus x cube is equal to 3. So therefore this expression x minus x cube is a cubic polynomial. And let us see third one. So in third one, here we have y plus y square plus 4. So here this expression is this is actually a polynomial in y variable with degree 2. Okay, so this polynomial is a quadratic polynomial. And fourth one, we have 1 plus x. So here 1 plus x, here the highest power of the variable x is 1. So degree of this expression, degree of the polynomial 1 plus x is 1. Therefore, this is a linear polynomial. And for fifth one, we have 3t. So here the degree of the polynomial 3t is 1. So therefore, this is a linear polynomial. And here r square, this is actually a polynomial in variable r with degree 2. So this is actually a quadratic polynomial. And here 7x cube. So here the degree of the polynomial 7x cube, this is equal to 3. Okay, so the polynomial 7x cube, this is actually a cubic polynomial. So now we will discuss exercise 2.2. Okay, so in first question here we have to find the value of the polynomial 5x minus 4x square plus 3 at point x equal to 0, x equal to minus 1 and x equal to 2. So let us find the value of polynomial 5x minus 4x square plus 3 at point x is equal to 0, x equal to minus 1 and x equal to 2. So here we can let p of x, this is equal to actually 5x minus 4x square plus 3. So now if we substitute the value of x is equal to 0 in this polynomial, then we get p of 0, this is equal to actually 5 times 0 minus 4 times 0 square plus 3, and this is equal to actually 3. So the value of p of x at point x equal to 0 is basically 3. And for second one, here if we substitute x is equal to minus 1, then we get p of minus 1, this is equal to actually 5 times minus 1 minus 4 times minus 1 square plus 3. Okay, so if we simplify it, then we will get this is actually equal to 5 minus 4 into 1 plus 3, that is equal to minus 9 plus 3, that is equal to minus 6. Okay, so the value of p of x is equal to 5x minus 4x square plus 3 at point x equal to minus 1 is minus 6. Okay, and now let us find the value of p of x at point x is equal to 2. So if we substitute the value of x is equal to 2 in the polynomial p of x is equal to 5x minus 4x square plus 3, then we get p of 2, this is equal to 5 times 2 minus 4 times 2 square plus 3, and this is equal to 10 minus 16 plus 3, and this is equal to minus 3. Okay, so p of 2, this is equal to minus 3. So the value of p of x is equal to 5x minus 4x square plus 3 at point x is equal to 2 is basically minus 3. Okay, so now let us move to the next problem. So in next problem, here we have to find p of 0, p of 1 and p of 2 for each of the following polynomials. Okay, so in first polynomial, here we have p of y is equal to y square minus y plus 1. So for this polynomial, we need to find p of 0, p of 1 and p of 2. And second polynomial is p of t is equal to 2 plus t plus 2t square minus t cube. Okay, so here we need to find p of 0, p of 1 and p of 2. And third polynomial is p of x equal to x cube. So here we need to find p of 0, p of 1 and p of 2. Okay, and fourth polynomial is p of x equal to x minus 1 into x plus 1. And here we also have to find p of 0, p of 1 and p of 2. So let us find. So in first polynomial is actually p of y is equal to y square minus y plus 1. So now p of 0, that is actually if we replace y is equal to 0 in polynomial p of y is equal to y square minus y plus 1, then we'll get p of 0, this is equal to 0 square minus 0 plus 1, and this is actually equal to 1. Okay, so the value of p of y is equal to y square minus y plus 1 at point y is equal to 0, this is equal to actually 1. Okay, and then p of 1. So if we replace the value of y is equal to 1 in the polynomial p of y, this is equal to y square minus y plus 1, then we will get p of 1, this is equal to actually 1 square minus 1 plus 1, and this is equal to actually 1 minus 1 plus 1, and this is equal to 1. So p of 1, this is equal to 1. And now let us find the value of p of 2. So p of 2, this is equal to 2 square minus 2 plus 1, and if we simplify it, then we will get this is actually equal to 3. Okay, so the value of p of 0 for the polynomial y square minus y plus 1, this is equal to 1. P of 1, this is equal to 1, and p of 2 is equal to 3. And now let us move to next one. So next one, here we have this polynomial p of t is equal to 2 plus t plus 2t square minus t cube. Okay, so this is a polynomial in variable t. Okay, so let us find p of 0, p of 1, and p of 2. So in second one, here we have p of t is equal to 2 plus t plus 2t square minus t cube. So now p of 0, that is actually equal to 2 plus 0 plus 2 times 0 square minus 0 cube, and this is equal to actually, this is actually equal to 2. Okay, so the value of p of t is equal to 2 plus t plus 2t square minus t cube at point t is equal to 0 is 2. Okay, and then p of 1, this is equal to 2 plus 1 plus 2 times 1 square minus 1 cube. Okay, and this is equal to actually 2 plus 1 plus 2 minus 1, and this is equal to actually 4. So the value of p of t at point t is equal to 1 is equal to 4. So now p of 2, that is equal to 2 plus 2 plus 2 times 2 square minus 2 cube. Okay, and this is equal to 2 plus 2 plus 8 minus 8, and here plus 8 and minus 8 will cancel, and this is actually equal to 4. Okay, so the value of p of t at point t is equal to 2 is 4. Okay, so now let us see third one. So in third one, here we have p of x is equal to x cube. Okay, so p of x is equal to x cube, so we need to find p of 0, p of 1, and p of 2. So let us find p of 0. So p of 0, this is actually equal to 0 cube, and this is equal to actually 0. Okay, and p of 1, this is equal to 1 cube, and this is equal to 1. And p of 2, this is equal to 2 cube, and this is equal to actually 8. So p of 2 is equal to 8, and then p of let us see the fourth one. So in fourth one, here we have this polynomial p of x, this is equal to x minus 1 times x plus 1. Okay, so we have this. So now if we find p of 0, then p of 0, this is actually equal to 0 minus 1 times 0 plus 1, that is actually equal to minus 1. Okay, and p of 1, this is equal to 1 minus 1 times 1 plus 1, that is equal to 0 times 2, and this is equal to 0. And p of 2, this is equal to 2 minus 1 into 2 plus 1, and this is equal to 1 into 3, and this is equal to 3. Okay, so now let us move to the next problem. So in next problem, here we have to verify whether the following are zeros of the polynomial indicated against them. Okay, so first we have p of x is equal to 3x plus 1. So we need to verify whether x is equal to minus 1 by 3 is 0 of p of x is equal to 3x plus 1. Okay, so let us verify it. So here, if x is equal to minus 1 by 3 is a 0 of the given polynomial, p of x is equal to 3x plus 1, then p of minus 1 by 3 should be 0. Okay, so here p of minus 1 by 3, that is equal to 3 times minus 1 by 3 plus 1, and this is equal to actually minus 1 plus 1, and this is equal to 0. Okay, so p of minus 1 by 3, this is equal to 0. So therefore x is equal to minus 1 by 3 is a 0 of the given polynomial. Okay, so now let us move to the next one. So in next question here we have p of x is equal to 5x minus 5. Okay, so here we have to verify whether the x equal to 4 by 5 is 0 of the polynomial. Okay, so we have p of x, this is equal to 5x minus 5. So let us check it. So here we have if x is equal to 4 by 5 is a 0 of polynomial p of x is equal to 5x minus 5, then p of 4 by 5 should be 0. Okay, so here p of 4 by 5, this is actually equal to 5 times 4 by 5 and minus 5, that is equal to 4 minus 5, and this is actually not 0. Okay, so as p of 4 by 5 does not equal to 0, therefore x is equal to 4 by 5, this is a 0 of the given polynomial, is not a 0 of the given polynomial. So x is equal to 4 by 5, this is not a 0 of this polynomial. P of x is equal to 5x minus 5. So now let us check third one. So in third one here we have p of x is equal to x square minus 1. Okay, so here we have to check whether x is equal to 1 and minus 1 are the zeros of the polynomial p of x is equal to x square minus 1. Okay, so let us check it. So here we have this polynomial p of x is equal to x square minus 1. So if x is equal to 1 and x is equal to minus 1 are the zeros of the polynomial p of x is equal to x square minus 1, then p of 1 and p of minus 1 should be 0. So here p of 1, this is equal to actually 1 square minus 1 and this is equal to 0. And p of minus 1, this is equal to minus 1 square minus 1 and this is also equal to 0. Okay, so p of 1 is equal to 0 and p of minus 1 is equal to 0. Hence x is equal to 1 and minus 1 are the zeros of the given polynomial x square minus 1. Okay, so now let us see fourth one. So in fourth one here we have p of x, this is equal to actually x plus 1 times x minus 2, and we need to check whether x equal to minus 1 and 2 are the zeros of the polynomial p of x is equal to x plus 1 times x minus 2. Okay, so let us check it. So in fourth one, if x equal to minus 1 and x equal to 2 are zeros of the polynomial p of x is equal to x plus 1 times x minus 2, then p of minus 1 and p of 2 should be 0. So here p of minus 1, this is actually equal to minus 1 plus 1 times minus 1 minus 2, and this is equal to 0 times minus 3, and this is equal to 0. And p of 2, this is equal to 2 plus 1 times 2 minus 2, and this is equal to 3 times 0, and this is equal to also 0. So therefore x is equal to minus 1 and x is equal to 2 are zeros of the given polynomial. So now let us see fifth one. So in fifth one here we have p of x, this is equal to lx plus m, and here we have to check x is equal to minus m by l is the zero of the polynomial p of x is equal to 3 lx plus m. Okay, so let us see how to check it. So if x is equal to minus m by l is a zero of the polynomial p of x equal to lx plus m, then it should be 0. Okay, so p of minus m by l should be 0. So here p of minus m by l, this is actually equal to l times minus m by l plus m, and this is equal to minus m plus m, and this is equal to 0. Okay, so therefore x is equal to minus m by l is a 0 of the given polynomial. And now let us move to the seventh one. So in seventh one here we have p of x is equal to 3x square minus 1, and here we need to check x equal to minus 1 by 3 and 2 by 3 are the zeros or not. Okay, so let us check it. So here we have p of x is equal to 3x square minus 1. Okay, so here if x is equal to minus 1 by root 3 and x is equal to 2 by root 3 are zeros of the polynomial p of x is equal to 3x square minus 1, then p of minus 1 by root 3 and p of 2 by 3 should be 0. So here p of minus 1 by root 3, this is equal to actually 3 times minus 1 by root 3 whole square minus 1, and this is equal to 3 times 1 by 3 minus 1, and this is equal to 1 minus 1, and this is equal to 0. And p of 2 by root 3, this is equal to 3 times 2 by root 3 whole square minus 1, and this is equal to actually 2 square, that it means 4 minus 1, and this is equal to 3. Okay, hence x is equal to minus 1 by root 3 is a 0 of the given polynomial. However, x is equal to 2 by root 3 is not a 0 of the given polynomial. So now let us check whether x is equal to 1 by 2 is a 0 of p of x equal to 2x plus 1. Okay, so let us check it. So here, if x is equal to 1 by 2 is a 0 of the polynomial p of x is equal to 2x plus 1, then p of 1 by 2 should be 0. So here, if here p of 1 by 2, this is equal to actually 2 times 1 by 2 plus 1, and this is equal to 1 plus 1, and this is equal to 2. So as p of 1 by 2 does not equal to 0 here, so x is equal to 1 by 2 is not a 0 of the given polynomial. So now let us move to the next problem. So in next problem, here we have to find the 0 of the polynomial in each of the following cases. Okay, so in first one we have p of x is equal to x plus 5. So let us find the 0 of this polynomial. So here 0 of a polynomial is that value of the variable at which the value of the polynomial is obtained as 0. Okay, so here first one we have p of x is equal to actually p of x is equal to x plus 5. Okay, so p of x is equal to x plus 5. So now if we substitute the so p of x equal to 0, it implies x equal to minus 5. So therefore, for x equal to minus 5, the value of the polynomial of p of x is equal to x plus 5 is 0. Hence, x equal to minus 5 is a 0 of the given polynomial. So now let us check second one. So in second one, here we have p of x equal to x minus 5. So if we equate p of x to 0, then actually we get x minus 5. This is equal to 0. And it implies x is equal to 5. Okay, so therefore for x equal to 5, the value of the polynomial p of x equal to x minus 5 is 0, and hence x equal to 5 is a 0 of the given polynomial. Okay, so now let us see third one. So in third one, here we have p of x is equal to 2x plus 5. So p of x equal to 2x 5, this is equal to 0. It implies x is equal to minus 5 by 2. Therefore, for x equal to minus 5 by 2, the value of the polynomial is 0. And hence, x equal to minus 5 by 2 is a 0 of the given polynomial. And now let us find the 0 of p of x is equal to 3x. So p of x equal to 3x is equal to 0. It implies x is equal to 0. Okay, so therefore, for x equal to 0, the value of the polynomial is 0. Hence, x equal to 0 is a 0 of the given polynomial. So now let us check sixth one. So in sixth one, here we have p of x equal to ax, where a does not equal to 0. Okay, so p of x equal to ax is equal to 0. It implies x equal to 0. Why? Because a does not equal to 0. Okay, so therefore, for x equal to 0, the polynomial p of x is 0. Therefore, x equal to 0 is a 0 of the p of x equal to ax. And then seventh one, here we have p of x equal to cx plus d, where c does not equal to 0 and c, d are real numbers. So p of x equal to c plus d, this is equal to 0. It implies x equal to minus d by c. Okay, so therefore for x is equal to minus d by c, the value of the polynomial is 0, and hence x is equal to minus d by c is a 0 of the given polynomial. So this is all about this lecture. I stop here this lecture. Thank you very much to all of you.